Okay, so I wanted to talk about problem number 57 again for you guys, since that was such a tricky situation today. Please notice on here, if you look, I've kind of outlined just how we're initially setting everything up. So I've got my little box of information, all of my little details here. This is my general picture with all of the given information. And then this is really important. I'm getting a lot of misconceptions about this triangle here. So one of the things that we talked about, so if you're in gold and you're watching, we talked about today, we had a misconception that the horizontal component of this triangle is actually the range, and then this is the height. So what we assumed was, what the misconception was, if we take a look at this trajectory and we cut it in half the way that I just divided it up here, well, we could say that half of the range is only 45. So like from here to here, we could call that 45 meters. Not 45, 49 meters, I'm sorry. Wow. So 49 meters, there we go. Which, yes, okay, that would be half the range. That's true. But this is not equal to 49 meters. That's not correct, because this is a velocity. It's a velocity. So this is not going to be, this component of the triangle is not going to be 49. That is not correct. Okay, so we cannot use that. What we can use is the relationship, to substitute, we can say that this is V naught times cosine of 45, or of theta, because that's just the relationship of cosine 45 is equal to adjacent over hypotenuse, where this is my adjacent value, this is my hypotenuse value, so we can say that this is true. And exactly the same way, we can say that my VI initial is equal to V naught times sine of 45, sine of theta. Of course, we know that sine of 45 and cosine of 45 are going to get you the same value, but that's not really terrible. That's not something that's always going to apply in the same problem. So if you're doing number 60, where the angle is then, where this angle is actually 51, then that's not the case. So let's just, not worry about the fact that these happen to be the same, so that these consequently happen to be the same, that these two velocities are going to be the same, because these sides have to be the same, because this is a 45, 45, 90. Okay. I don't mean to talk too fast, I just don't want to take up too much of your time. Okay, so basic picture right here. Now I'm going to go to my next slide, and on this slide I want to go over the math that we're going to be doing with this problem. So first, let me go ahead and zoom in on this chart, and let's start filling in what we know. Okay, so from my previous slide, I do know that this is equal to V naught times sine of theta, and I also know that Vx is V naught times cosine of theta. Other pieces of information that I'm given are that the range is 98 meters. The change in height is, of course, 0 meters, because this is a type 2. We don't know the height at the apex. We know that the final velocity at the apex is equal to 0 meters. We know that the final velocity is equal to the opposite of the initial velocity, which is going to be negative v final, or excuse me, v naught times sine of theta. And then if we can use the equation, let me get another color here, that time is equal to negative 2 vi divided by a, then we can say that time is equal to negative 2 times vi, which is v naught times sine of theta, divided by a, which is the 9.8 meters per second squared. So I'm going to just put divided by g right there. So we've now filled in all of that information, and we know that this is the same thing here. Okay. So the reason that I did all of this is now the only variable that I have in any of these problems is v naught, v naught, v naught, v naught. Everything else can be solved for a number, well, with the exception of this. But I'm not going to deal with that because I don't need to deal with it in order to solve this problem. It's going to be, in order to find this, I would have to use some constant acceleration equations to get here. You know, one of my like 1/2 at squared blah 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 equations, or v final squared is equal to v initial squared blah blah blah. But I don't want to do that because that takes a lot of work. I would like to do something more simple. And I can do things that are more simple on this side of the situation because this is constant velocity. And I can use my constant velocity equation that my range, or the distance that I'm traveling, is equal to the velocity in the x direction times time. So I can actually do some substitution that's really easy here. And if you'll just, walk through this with me, I think you'll find that it's not quite as scary as it looks when it's up on the board. So just go through it nice and slowly with me, okay? All right, let's try to move this over here so that we have a little bit more space. There we go. Hopefully that you guys can still read that pretty easily. But let's now take a look at how we're actually going to plug things in to this equation so that I can solve for v naught. Okay, so that's what I'm doing here. I don't know t, I don't know vx, but I do know r, and I can actually substitute in this equation for vx and this equation for time, and then the only variable I have left is v naught, so that I can solve for v naught. That's my ultimate goal here. So let me go ahead and start rewriting this so that we can do that. So r is equal to vx times t. Kind of divide that over. Okay, excuse me. There we go. Okay, so we know that r, it was given that r is 98 meters, and that's equal to my vx part, which is v naught times cosine of theta, times my t part. Let me shrink this down a little bit so that we can kind of, okay, no, now I can't do that because now I'm running out of, all right, sorry guys. Let me just go down to the next line then. So then that is multiplied times t, which is negative 2 vi over g, right? Okay, and so then if I rewrite that part, we can say that that's, need more colors. You guys probably don't need me to be quite so color-coded, but I feel like it helps. I'm going to rewrite this now so that I can get rid of that VI there, because we already replaced it. So that's V naught times cosine of theta times -2, and VI is V naught times sine of theta divided by G. Okay, the physics is now done. At this point, we've related all of these things together so that I only have one variable left now. That only variable left is now, not that. Nope, poop. The only variable that I have left now is V naught. So I need to get everything as simplified as possible. So at this point, guys, I'm not doing physics anymore. All I'm going to do is algebra from here on out, okay? So if you know how to do the algebra part, then you're fine. If you don't know how to do the algebra part, then keep watching. Okay, I'm going to shrink that down so that I can write below it. Shrink that one down even more. I hope you don't mind that I'm shrinking these down. Okay. So now I need to take G. The first thing that I'm going to do, I think the most convenient thing for me to do is going to be to multiply G on both sides and get that one out of there. So then I can rewrite this as G times 98 meters. I'm going to stop color coding now. Is equal to V naught times cosine theta times -2 times V naught times sine of theta. Since these terms are just multiplied together, we just multiply them all the way through. We don't have to do any distribution because there's no addition here. So simplifying another step, we still have G times 98 meters is equal to, if I'm going to combine my V naughts, then I'm going to have V naught squared times -2 times cosine theta times sine theta. So now I'm going to get V naught all by itself. So let me divide this whole thing by -2 cosine theta times sine theta, divide by -2 cosine theta times sine theta. Move this up now. Okay, so now I've got V naught squared is equal to G times 98 meters divided by -2 times cosine theta times sine theta. And so then if I take the square root of both sides, I have then solved for V naught. And that is all you got to do. I hope that helps. See you guys on tomorrow or Friday. Bye.